All right, guys, so you took the test. It didn't go well. Let's try to recap this information one more time. Um, it all starts with matter, and that's because the goal of this unit is to be able to develop and use models to describe the law of conservation of matter. And so we have to understand what matter is to know what it is that we're conserving. So let's start with this. Matter is what makes up the world around us. It is anything that has mass and volume. Basically, anything made up of atoms, and that takes up space. Atoms are what gives matter mass, okay? Gives it something that we can weigh, all right? And it is made up of the elements. Okay, the elements are the things that we find all around us, and they are labeled here on the periodic table. Anything from the hydrogen that is in the water that we drink, to the oxygen that is in the water that we drink, to the helium that we use to blow up balloons and make them float, and the carbon that forms the backbone for most living things. So these elements are what makes up matter. Okay. Now, we can keep going. The elements can exist as an atom, which is a unit of matter and represents just one element, or as a molecule, which is represented here by my example COO, carbon dioxide, which is more than one atom bonded together, but it's still matter. Why? It's made up of atoms, right? So to recap once more, atoms are what makes up matter, okay? And molecules are more than one atom bonded together, but they also make up matter. Again, atoms are what give matter mass and why mass takes up space. This is why the number and types of atoms in the reactants and products of a chemical reaction do not change. We cannot create or destroy matter, aka atoms. Let's keep going. The law of conservation of matter states that matter cannot be created or destroyed in a chemical reaction. Atoms are matter. We cannot create them. We cannot destroy them. But molecules are not so tough. Okay? Molecules can break apart. They can rearrange. They can form new substances as long as we do not destroy the atoms that make them up. This is why, in a chemical reaction, the atoms must stay the same in the reactants and products, but the molecules cannot stay the same. The molecules have to change. That is what a chemical reaction is. The atoms must rearrange to form a new substance. Why? Because chemical reactions create new substances, but they do not create atoms. They just rearrange them. And that is where chemical formulas come in, because the chemical formula and the models of the atoms and molecules in them are what we use to understand what is happening during a chemical reaction. So here's an example. 2HCl, hold on. 2HCl, that means two molecules of hydrogen chloride or hydrochloric acid. That's this stuff right here. It's pretty nasty, okay? It's an acid. It eats things alive pretty much. And magnesium, this metal right here, if I mix this with this, the atoms in this are going to rearrange and form new molecules out of these things. I'm going to show you, literally. What I'm about to show you is the reaction between hydrochloric acid and magnesium. And all I need is a test tube with a little magnesium, my hydrochloric acid, and a dropper. This is nasty stuff. You don't want to touch it. A dropper full of hydrochloric acid, my magnesium, and chemical reaction. Check that out. It's awesome. Pretty cool, right? So what is happening right now between this hydrochloric acid and this magnesium? That is where, let me put that down for a second. It's kind of scary. Hold on a second. This is where the chemical reaction and the chemical equation and the models that we're using come into play. The atoms in the hydrochloric acid are rearranging with the magnesium to form new substances. And we can figure out which substances are forming if we know a little bit about the chemical reaction. Look at that, it's still fizzing. Pretty cool, right? You can even hear it maybe. I don't know where my speaker is, but you can hear it. All right. So I don't know if you guys noticed, but there was clearly something coming up out of the top of the test tube, and it was a gas. And we can figure out what that gas is using our knowledge of chemical reactions, of matter, and of the law of conservation of matter. So let's go back to looking at, put this stuff away, this chemical equation. Here we have 2HCl, and we just reacted it with magnesium. And during the reaction, there was a lot of bubbling and fizzing and scary. And in the products, a substance formed called magnesium chloride. And also another molecule formed of a gas that was escaping from the top of the test tube. But what was that gas? Well, here's where we use modeling to figure that out. So I'm going to go over here and I'm going to create a model. Here in my reactants, that's this side. This is all the reactants, by the way. 2HCl plus Mg is the entire reactant, all of it. Not just hydrochloric acid, not just magnesium, because this by itself does nothing. This by itself does nothing. I have to put them together in the test tube to get something to happen. They are reacting. That's why they're called my reactants. So let me scroll down just a little bit here and I can help you out. So I'm going to choose my circle tool, and I know that this 2 here means that there are 2 molecules. That's what the big number means. It's called the coefficient. It tells me that I've got 2 molecules of HCl. So H is hydrogen. I'm just going to represent that as one circle with an H. Copy and paste that. But it's not just H, and it's definitely not HH. It's HCl, hydrochloric acid. Again, hydrochloric acid, that's this stuff, okay? Now the hydrochloric acid, there's not just one molecule of it. I'm looking up here, I'm seeing that there's 2 molecules of it. Get my pointer back here. So I need to make 2. Now they're not touching each other. It's just how many molecules of hydrochloric acid it takes to get the reaction to happen. 2 molecules of HCl. That's half of my reactants. But what about the other part? Well, I'm going to separate these by a plus sign just like they're separated up here. There's my plus sign. Here is my HCl. But what about my Mg, my magnesium? Well, magnesium, that is just one single atom of magnesium. That's all it takes, just one measly atom of magnesium. And that is going to stop the video for now. And when we return in video number 2, we're going to learn what happens in the products.